Okay, let's try another example. We've got our parametric equations here. 5 sine t, 5 cosine t. Now, graphing, pretty straightforward, right? I just want you to jump into Desmos. Here I did it. 0 to 2 pi for this one was fine. Hey, it's a nice circle, okay? So coming up with the graph should be pretty straightforward. Let's rewrite it though as a rectangular equation. That just means we get rid of the t, basically, okay? Now up here, notice I put some identities we've seen before. These are our Pythagorean identities, just to kind of remind us. They're on your trig sheet. So let me show you a method how we could clean this up. So let me just rewrite. X equals 5 sine t and y equals 5 cosine t. Notice I'm not going to be able to solve for t very easily in here and get rid of that. So here's another method. Let's divide my 5 over in both of these. So x over 5 equals sine t and y over 5 equals cosine t. Now here's where I'm going to bring in an identity. What if I squared both sides of these? So squared, 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 and squared. Well, what's sine squared plus cosine squared? It just equals 1. So let me rewrite that. So sine squared of t plus cosine squared of t equals 1, right? So now let's substitute. Well, sine squared is the same as x squared over 25, if I square this, plus cosine squared is the same as y squared over 25 equals 1. Now if we wanted, we could multiply 25 by both sides to get x squared plus y squared equals 25. Hey, that's a circle radius of 5, right? Which is exactly what we saw in the graph. So there's a good strategy, and that we're going to use these Pythagorean identities to help us with that. So let's go try a few more like that.